Okay, so good morning everyone. So I hope everybody tried the map reduce, and we received some issues during the reducer issues, and that is because of some version issues. So we are working on that. So anybody other successfully ran the map reduce code or facing any other issues? Yeah, voice is very low. That's everyone I am checking. What is the issue? Okay, yeah. I already connected the mic. How about now?
Yeah, somewhat okay.
Okay. Switch to phone audio things. Hello. Okay, volume is fine and same system. Okay. Okay. I hope now it's okay. So yeah, how many of you able to successfully run the map reduce code? And we faced some issues. I think Anbuji has some issues. I think.
No, this is Anand.
Yeah.
I also had the issues, Arji. Remember,
Yeah.
like I sent you that it's on the day the issue. Which
Yeah.
you tried.
Reduce is not found, right?
Yeah, map reducer is
Okay.
having an
Okay.
issue.
That is. I checked that one. What's happening? The issues. It might be because of the latest version. So we need to change the jar version. So that's
Okay.
what I am just looking into that. I'll send you the new jar. I'll just send you the link of new jar. You can download it, and
Okay.
you have to add that and build the jar. Then I think it should be fine.
Okay.
It's
Yeah.
because of the version only. It's old one, so that's why it's.
So you want me to delete all the jars and re-put it, or
You
you
have
have
to
one?
just replace the jars with the one which the link. I'll find the link and send you. You have to just use the links only. Those jars only. The
Okay.
reference jar.
Yeah, I got it.
Okay. So any others tried or any issues or any? Okay. So fine, we will start with Sqoop today, and we'll go on. We'll parallelly also check in the MapReduce codes. And once the Sqoop is done, Sqoop is kind of easy. It is not that difficult to work on. So we'll work on these things. Okay, so Sqoop. What is Sqoop means? Sqoop means SQL plus Hadoop. That is what we are calling it as Sqoop. Before going into Sqoop and all, let's first understand. So as of now, I guess everybody understood what is Hadoop and where it is there and what is SDFS, how it works. I hope. So this is SDFS. This is what our SDFS means. This is the SDFS system is there, and so what is the use of SDFS and what kind of operations we are doing in SDFS? Can anyone tell? Overall, what is the use case we are doing?
Just storing data.
Storing the data in a blocks.
Storing data. Exactly. Storing the data and somehow processing the data, like later batch processing the data. So for that, data has to come from somewhere else. Data does not get generated in SDFS itself. That is not going to happen. That's not happening. And we are not using SDFS for OLTP transaction or something like that. So everybody is clear in this one, right? data is not getting generated in SDFS itself because it is not a backend. It's not like we have some front end like IRCTC website or Flipkart website, and background we have SDFS as serving as a database. It is not like that. Is it? Is this understanding is clear with everyone?
Yeah, yes, Saroji. Yes.
Okay, that is good.
Yeah.
So
Just a hard disk.
yeah, it's just a like storage for where we can do analysis of the data in a batch processing manner, or we can store the data for later retrieval. And it is kind of somehow slow. It is not that much faster. You cannot retrieve it within a second's time. No, it's not possible. Okay. So keep in that mind. Let's say whatever we have data, whatever the data generation points are. So how the data is getting generated through websites. Website traffic generates data for the website guys, and the social networks and machine generated data, and third party logs and application logs, and any other data anyone can tell what kind of other kind of data which we generate.
All IoTs. All IoTs.
IoT, that is also machine generated. Any other data other than this? Manually enter data.
Any script or batch process data?
Batch process. Batch process, what kind of data it might generate?
No, the script, if you want to run any script for batch process, then we can store it, correct?
Store the script, right?
Yeah.
No, we are not talking about script. We are talking about the data. Like application log is a data, third party logs is a data, machines that generates data, machine generator. If you run a machine for some time, it generates some data. Nowadays, every machine generates data, right? Like our watch, smart watches, phones, everything generates data. Something like that.
What about relational database data?
Yeah, exactly. Relational database data. That is a backend data, right? Backend. RDBMS that is getting generated in website and so many places. Like everybody uses RDBMS as a backend, right? Any other of like say a format or use case of data?
Semi-structured and
Semi-structured and structured. It comes in any one of this one. Like unstructured is some kind of loosely generated data or something like that, right? So we can say legacy data overall, which cannot be which might not be formatted, semi-structured, structured, something like that. So all these kinds of data, it is not available in SDFS itself. It is available outside the SDFS. So first our task, if any Hadoop project comes or anything comes, our first target is to bring this data into SDFS. That is what our first step at any point. So bringing the data into system, that is what we call it as data ingestion. Okay. So for this, there are different kinds of data. So there are different kinds of needs. So we can, for example, if we have a third party logs or application logs, which our client gives us into some FTP server, because these logs might be day 1, day 2, they might be having. So that what they will do is they will simply do the FTP or SFTP, secure file transfer protocol they'll use, and put it into our Linux system. This we can import into SDFS simply using the put command, like very normal shell script command, which we use put command and we write a shell script. We can easily bring the data into our SDFS platform. Okay, that is one kind of data. It is not an entire kind of data. There are other kinds of data also there. Okay, so if the it is only based on what kind of data we are dealing with and how the data is getting received in our end. Based on that only we have to decide what kind of ingestion tool or what kind of ingestion method we are going to use. Okay, so for that, if the third party logs comes as a file, sometimes data just comes as a file in our end. So if that is the case, then we don't have to worry. We can just write a shell script and then put the data daily or weekly or 3 hours once, whatever it is. Based on that, we can schedule the script so that once the script runs, it will put the data into HDFS. That is the one way of doing it. And sometimes or most of the times, where the data getting generated is RDBMS. Okay, so RDBMS, how the data is getting generated? Whatever we are doing, the backend will be RDBMS. Correct. Currently, that is a very strong one. That is what getting generated. So RDBMS is also having data for 15 years. Some companies or most of the companies having 15 years of data there, data residing in RDBMS, or some companies having like large number of data or something like that. Correct. So if we want to bring this data, like you have a data in RDBMS that you want to bring it into HDFS for some kind of analysis. Fine. So for that, what we can do? Before that, why do we want to bring the RDBMS data into HDFS? Okay, we are bringing the data into HDFS, that is fine. But before that, we will ask, why do we need to bring the data to RDBMS? What is the need? Can anyone tell? Why don't we just process everything in RDBMS? Why do we need to bring the data into RDBMS?
No, I think the question
For the
should
better
be,
speed.
Speed,
the
okay.
question should be like, why do we need to bring the data to HDFS, the RDBMS data?
Okay, data from RDBMS. Yeah, it's 2 means why do we need to bring the data to HDFS?
HDFS.
From RDMS.
From RDBMS. Yeah, that is the right question. Correct.
One is speed,
Speed, okay.
then
And
storage,
Storage, okay.
Improve the performance or processing time.
Processing time, okay.
we can get the correct statistics of the data.
Cross-platform usage, okay, that is also fine. Correct.
Analytics.
Analytics, yeah, fine. Analytics, correct. Somebody said something else, right? What is the one which I missed?
No, it will come under analytics like.
Okay. Yeah. Yeah. So roughly we have this kind of usage. So let's check. Let's go into one by one. So speed. So if currently, as per whatever we know, HDFS is not that much speed compared to compared to RDBMS. That is a one point. But if the data grows into, I think somebody is not in mute. I'm just muting. Yeah, I'm just muting everyone so that the idea will be clear. Okay. So first, what will be the need is, let's say your RDBMS system, we have 100 GB of data for 1 quarter. Q1 2018, we have 100 GB of data to be processed, and you are generating one report to be generated. Yeah, it is fine. We are able to generate the report. It is works fine. And so after that, what happens is Q2, quarter 3 happened, quarter 4 happened in December. So what the company wants is, they want the entire year data, entire year report they want to make. So in that time, what happens is, the data which happened for 1 quarter, here it is 4 times the data of 1 quarter. That time, if you run the same report for 4 quarters, the report might hang. The RDBMS might hang. It is not able to process that much data. Or if you wanted to run a report for 10 years of data or 15 years, something like that, which consumes huge data, in that time your RDBMS or the system cannot able to run that much data. That much data, the report is not able to run. That is started getting hanged. So in that case, what we usually do? What
But
is the option?
RJ, that could be the front end tool which is being used. It's not that RDBMS is not capable. No, it's a
No.
usage of the
RDBMS
report.
itself might not capable. I can tell you the reasons. which of the you might use Oracle or SQL Server?
Teradata.
Teradata, okay, right. So Teradata has some more limitation than other RDBMS. So that's what the thing. You haven't reached the peak of Teradata yet. That's why I think you are telling. But what usually happens is in SQL Server and all, for the client whom I work, they are running for yearly report, or sometimes they wanted to run 15 years report as yearly ones. So from the beginning of the data they have to run. In that time the report will hang. It will not at all come. So for that, what could be the remedies we have to do? We can optimize. We can optimize the query, number one, correct? If something happens, we can optimize the query, right?
Yeah, yes.
Yes.
Yeah, okay. So we can optimize the query, or what happens is we can
Optimize the resource.
optimize the results.
Resource.
Resource, yeah, exactly. Optimize the resource and we can try. Or what we can do is we can
Or we need to purge.
separate.
Or can the report.
Can the report, like we'll do the we'll run for some other segment, some segments like that. Like that,
Materialization.
separate.
Materialization.
Yeah,
Create the materialized view. Yeah.
Yeah, exactly. That we can do. Or one more thing, what we can do is we'll run for 3 years, and then finally we consolidate the report. That is possible. Correct. If you want to run for 15 years, I'll run first 3 years report. I'll run. I have to make the data into smaller part and run, and then finally, and the result I have to I have to consolidate the result. Something like that I can do. So those are the remedies which we can do in providing you have the limited resource for your business. Correct. So those cases, currently what the projects are doing is they bring all the data into HDFS. They bought this data into HDFS. They do the processing here. They run the report here, and then they bring back the result back to RDBMS. That's what currently some of the projects are doing. So what's happening here is you have a data in RDBMS. So let's say this is RDBMS. RDBMS. Bring the data into HDFS. This is HDFS. Bring the data here and then do the processing and run the report. Lastly means run the report. We have to develop the report here, everything we have to run, and it will get a result. And after the result will be pushed back to the RDBMS again. So why do we need to push back the result here? Means here we already have the reporting tool connecting to that, so that clients can view. We don't have to develop those things, dashboards. Okay, so that large data, like we can bring the data bring the data to HDFS and do the processing in Hadoop, HDFS and Hadoop, and then bring back the results here. Fine. So this is one of the use cases where we need to bring the data from RDBMS to Hadoop, and then process and then bring back. Fine. And some other time, what we want to do is the data might not be too much important. For that case, what we do is they simply put the data into HDFS for storage purpose. They simply have the HDFS environment as a data warehouse. That is a use case too. Use HDFS for processing. Use it for storage warehouse. For this also we need to bring the data. We'll bring the data from RDMS to here and then just store it. Those part also is there. Okay, these are the basic examples where at what scenarios we need to bring the data from RDMS to HDFS. Fine. Any questions till now?
So just to understand, whatever you explained, Aru, yeah, I know the process, how they are handling as of today SDFS and RDBMS. Basically, they want to take the load out of the appliances and put it in the low-cost commodity, execute it during the night time, and then before 6 o'clock, load everything what is needed for the report, and then from there they will take it up. So they can reduce the load from the RDBMS, right? So I understand that part. So I have another question. So what kind of data will sit in HDFS, and what kind of data they wanted to move? When you say they are moving only report, so report data alone will not work in the RDBMS, right? For example, if you need 15 years of data, if you take 15 years of transaction data, definitely you need the corresponding dimensional data to support the 15 years of transaction data, right? So in architecture wise, how they are deciding what table needs to be in HDFS and what table needs to stay back in the RDBMS instead of HDFS.
Okay. So if they are taking the data from here, it doesn't mean they are deleting here. It is there also, it is here also, and whatever the data, like in the report wise, I'm not saying only one table they will move. No. If they require for the particular report, if they want 100 tables, they'll move 100 tables from here to there and create the report there, do the processing there. And if the data is sensitive, and if the data is necessary or needed for other purpose in RDBMS, they will not delete in RDBMS also. It will be there also. But for the processing sake only, they are moving into HDFS. So whatever the table they want, they will move it that also along with that. That based on the what kind of report they want.
Okay, got the point. Let me ask you this question also. So now you explained the RDBMS, which was built long back, and if any company wanted to get rid of the load, then they can follow this process, right? But instead of moving that into RDBMS and bringing it back to Hadoop again and cook it and move it back to RDBMS again, can't they do a process to bring it from the truth of source to HDFS and cook everything before they put it in the RDBMS and move whatever is needed into RDBMS? Is that the right approach they are following, or which approach is highly followed in the market?
Whatever I'm saying, this is approach very highly followed. It is above 80%, and nobody like Hadoop is not real time. That's why you cannot. Once the data comes, you cannot immediately do the processing or cooking and then put it into RDBMS. No, that is not at all happening in anywhere. Whatever I see in the projects, so that is still way to go. But whatever you said is fine. In future, that might get developed because of the real time processing engine like Spark, and those things are coming. Because of that, that might be possible. But currently, that's not possible. Because we cannot rely for a fast time or real time over there.
No. What I mean to say is, I'm not asking whether the HDFS can work as a real time, but even if you want to move the truth of source data into RDBMS, it's going to be nightly process. Right? Night jobs will run. It will move the data into the staging table. From there, it will go to the base table. Then the reporting layers will run based on the base tables. Right? That is the process. So the moving into staging table, doing the transaction, moving to the base table, it's very, very straightforward between the transactional and the analytical system, right?
Correct.
You need to make any big process there. That is not real time at all. So those things, for those purpose, will they be using RDBMS, or purely it is used to cook the data and put it back into RDBMS?
No. The transaction to base table, which what is the process? Can you tell again?
Okay. For example, today I'm working in a insurance company, right? The claim and the member process, client process, everything will happen in the front end side, in the facets, right? The facets will get fed into RDBMS in the nightly cycle. It can be a weekly, it can be nightly, depends on how your business runs, right?
Okay, correct.
So how it is happening today, the source system will either put it as a file into a server where it will be read by the native tool or by Informatica, whatever it is. They move it to the staging table. From there, the transformations will happen, and then finally it is going to the base table based on the DQA steps. This is one process. Otherwise, your Informatica will directly read it from the transactional RDBMS. It will do the process, or it will just do the ELT and then do the transformations and then move that. This process is very, very transparent, right? This is not for live active things, right? This will happen during the night time, so that the data will be cooked and it will be available next day morning for any report if it is needed.
Yeah, so in this case, whatever the transaction before base table also, we can insert HDFS here. We can do the processing there. That is happening.
Okay, that's what I asked.
Here also we can insert HDFS. Yeah, that is the correct one. Here also we can insert because it is not real time. It is a batch one. We can take insert it here. That's possible. Correct. We can do. Yeah. So.
But ideally, in the real-time situation, nobody is doing inserting back to the warehouse tables. If at all they need any data, whatever the aggregation with includes the dimension keys and as well as the fact data together come as a separate table into a relational database, and from then that could be called as a reporting layer. From then the reports will be generated. Though nobody will mess up with the existing data of relational with the HDFS.
Yeah. Currently, nobody is doing that. Just you bring the copy to HDFS and process it and bring it back. That's what's happening.
That's it. That will come to a different table altogether.
Yeah, that will come to the different table. Reporting table it will come. And
right.
More thing is, whatever RDBMS cannot do, that you have to do in HDFS only. Those kind of opportunities are opened up right now, because you cannot do unstructured data processing and compare it and do those analysis. That is not so much possible in RDBMS, which is now possible. The multiple sources that we can bring it to HDFS, and we can do the analysis with the RDBMS data. Those kind of possibilities are there currently. So that will come into that's opened up a more like horizons in HDFS, I would say. That's a processing also happening. But that is also altogether a different source. That also there in HDFS. And you can bring log data or unstructured JSON data, XML data, or you want Avro data, okay, bring Avro data. Everything is possible. We can bring it to HDFS. One source, whatever we are seeing is just one source of HDFS, that is RDBMS, but that is what most of the companies are using. Other source also there. So for that, different tools we'll use. Okay. Fine. So any others, any questions, or everybody still know whatever we discussed? Clear? Vignesh ji, Vinod ji, Selvam ji, and Ganesh ji, and Buji. And
Yeah.
Winston here. I have one question.
Yeah.
So looks like, just to add on to Vinod's point, RDBMS to HDFS. So we only use HDFS when the data is very high, right? So if we are doing a nightly process or a weekly process or a monthly process, the data would be relatively small. So that means whenever we want to process something on HDFS, it has to be huge amount of data. That is, we definitely need to write a job to copy the data from RDBMS to HDFS and do the processing there, right?
Correct. Yeah, that is right.
So nightly and weekly, we don't have to push the data into HDFS.
Yeah, so that is where we have to take a decision based on the projects. So some of the one project which I seen, that has delta load around 1 GB of data will be there as a delta load. Okay, 1 GB of data will be there. What they do is they daily put the 1 GB data into HDFS. They might not have the daily report. They have only weekly report, but daily, as soon as the job runs, they scheduled this job also, so that the delta load just go into HDFS and resides there. And whenever they want to pull the report, they can pull it. So when some of the companies or some of the projects using HDFS just for storage purpose, then they will insert the daily load also as a daily job into HDFS itself. So it is purely based on project decision. Some projects they use for delta load also, for daily load also, because they have only one report, so they can run it. That's what they're thinking.
Okay, Aru. Can I ask you one question? So this is just to understand whatever you explained, that makes sense to me perfectly. But just wanted to make sure I understand the reason why they are using HDFS and what savings they are going to get it in RDBMS. Just from the architecture side. Okay. Let me ask you this question.
Yeah.
So in your example, you said if people need 15 years worth of data, which is in TB, it is very tedious to process the data for the reporting, right?
Correct.
Let me tell you this. Usually, if you need something for the reporting, the report is not going to access the 15 years of data at the lowest grain, right? Definitely, they'll be needing it in a high level basis so that you can cook it and keep it within database itself during the night time. Morning, it is going to be consumed for the reporting purpose, which will be very, very less rows comparing with the lowest transaction, right? This is my understanding. Let me ask you my exact question here. So you have 15 years worth of data anyway in RDBMS, and you are moving the 15 years worth of data into HDFS very first time, and then from the next time itself, you need to move the incremental in order to process the same report in a weekly basis or a monthly basis. Agree?
Yes, agree.
Okay. So what I understood from your statement is, anyway, the data is still residing in RDBMS, and only the CPU process during the night time, what is going to happen in RDBMS is getting moved into HDFS, right?
Yeah, right.
So what we are going to achieve out of that, for example, if I'm reducing the storage of the RDBMS, that makes sense to me. Or if I'm reducing the CPU during the daytime where all the users are using the RDBMS system, that time if I reduce the CPU, yeah, that makes sense to me. But during the night time, anyway, no users are going to be there. Why do I need to move the load to here if something is going to happen during the night time and cook it and put it into the RDBMS before 6 o'clock for the portal? Just to understand that.
Yeah, I understand the question. So few things. First is RDBMS is kind of costly compared to SGFS. Agree? So that is a one use case. Another thing is currently SGFS is not that much reliable. That's why they are not deleting the data in RDBMS. So after some time, what they will do or they are going to do is they will keep let's say the company A can like decided, okay, I can store 3 years of data in my RDBMS. They can say RDBMS due to the money constraint or resource constraint or something. Now, just because SGFS comes, what they can do is, okay, I'll do the 3 years of data in RDBMS and I'll store 10 years of data here because it is cheap. So they will slowly remove the data from RDBMS and they will move into SGFS. That's what's going to happen in future. Already some companies are doing such like that. So that is going to give them a benefit. Like slowly they will move it. Like whatever data is not that much used or whatever data is not critical data. Currently that's what's happening. Non-critical data are being moved to SGFS itself. It is not there in RDBMS. So those transactions can happen. That will be moved into SGFS. That will be huge benefit.
Yeah, like Vinod, what can we do is like that we can accumulate 30 days of data in the RDBMS. So upon the 31st date, we can move the last day, the first day of transaction, right? So we can just move it to that HDFS. So it will keep on adding for every day, right? So we'll be keeping only 30 days of data only in RDBMS. The old data, so we can just store in the HDFS.
This is Anbu, right?
Yeah, this is Anbu.
Anbu, yeah, I got that point completely. But moving that 1 day data from one table is not that much easy, right? And in order to do that ETL process in RDBMS, you need to refer so many tables. So which says that unless or until you move the complete table from RDBMS into HDFS, you can't really just take 1 day of transaction data and accumulate that into HDFS. That won't make sense.
Yeah, I will say like one small example. Like NASA is doing some analytics, right? So there are so many satellites, so there are so many controls. So every controls is producing one data. So they want to maintain that. So they can move those data into HDFS on daily basis. they can keep some of that data only in the RDBMS, right?
We can take it later on. Yeah, I understand your point, but what I'm trying to say is, unless or until you have the reference data, just moving the data, transactional data alone. For example, climb. If you just move the climb, nothing is going to help you if you have that table alone into HDFS.
No, not one table alone.
Yeah, exactly.
They
It's
need
not
to
one
load
table.
the most of the tables.
Every table.
Vinod and Anbu, one point is they will not just move one table, so dimension along with the fact will be moved. And to clarify one question with Aru data lakes, right? They are directly doing a reporting out of the HDFS.
Correct.
Right?
Yeah.
So now the reporting, there are reporting tools which are built on the against the HDFS, which will be very, very much faster than the going against the RDBMS.
Yeah.
So
those tools are currently evolving. It is not like it is starting point only. That's what I would say.
So no need to go back to the database to build a report.
Yeah,
they
correct.
can do against the HDFS also.
Yeah, that is currently coming. But if you look into sensitive data, currently that is they are not moving in. That is only for other data, like non-sensitive only they are moving. HDFS is currently came like more reliable, but it is not up to the point where it can entirely you can replace the data whatever you have in RDBMS. That till that stage it didn't came. But yes, there are some companies which have data lakes. Data is only there in HDFS. From there itself they are doing. And when we say we are moving data from RDBMS to HDFS, this is not one table. Whatever table we are necessary, whatever table updated today, move all the tables from here to there.
No, Aru. Yeah, I understand that. I just asked that question just for Anbu's question. But my thing is, if you want to move everything, my personal thought is, what I want to understand clearly is, moving complete data into RDBMS, again moving the complete table into HDFS just to cook the report data and out and then put it back here. That's what my question is. It's like using the two resources heavily, right?
No. Once you move the data from here to here and once you generate the report will not be much bigger, right? The report is what?
No, again, Aru, I think again you're not getting my point. For that 15 years worth of query output, right? It is not that you can just make it with one table, right?
Correct.
If it is that much easy, you can do the same thing in RDBMS. You are moving it because you need to join it with, you need to make so many joins and so many complex logic to cook the data finally, right?
Correct.
So you need to move all the related data from here to HDFS.
Correct.
Right?
Yeah.
So that movement is happening twice in your system. One to RDBMS and next to HDFS.
Okay. Here and then from here to here you're saying.
Exactly.
Okay, understood. But here right. It is already happened, right? It is generated in 15 years of time.
So right now, nobody is not ready to go to directly to the HDFS because they want to see the performance, how it is really working.
No. Just to let you know, Bank of America, long back, even 6 years back, they used HDFS as the middle layer. They moved complete tables from RDBMS. They have a complete architecture in HDFS. They are using it like that only.
No. For which kind of data?
For transactional data, completely it is coming into Hadoop first.
Okay. So,
and then including reference data, all transactional data is coming to Hadoop. It's getting processed during the night time, including the ELTs, the transformations, the DQA check, everything is happening in Hadoop. And then finally, the final data, the required
Vinod, then you cannot call it as a transactional data, correct? It is a analytical only. They just use it for storage, though it is called it as a transactional data, but they are not processing it immediately, correct? They are just using it as a batch.
No, I never called it as a analytical data, transactional data. That is a transactional data coming from the truth of source to HDFS instead of directly going to the RDBMS.
Source, what do you mean by source, G? What is the source?
The system that feeds the transactional data to the analytical system.
Yeah, what is that?
Okay.
That is
what
RDBMS,
is your,
right?
Yeah, that is again RDBMS.
Exactly, that's what here also we are saying, right? That is RDBMS. That's what it is not like the point here is it is from RDBMS only. Like we cannot directly connect the HDFS. Like
Vinod?
That's what we're saying here, right?
No, Vinod's point is also right, because one of our in our client there is one project. Currently, what they are doing is they are migrating all the historical data to the cloud, and again the future state of the project will be in cloud. The regular load will be in cloud, and from the cloud, they will whatever the data related to the reporting, they are pushing back to the on-prem. That is the plan. So they are moving towards that. So it is all companies how they want it. Either you can keep it this way and that way, or it's their choice. If they are really comfortable in HDFS, then they will go for the whatever Vinod said. So if still they are not in comfortable, they will move from this way to that.
Yeah, I think Anbuji, right? So Anbuji, the point is the source, whatever you are saying, the Bank of America, they have used one source, right? So in our example, this is what we are seeing as source. You are right. So this is the source. The source is anyway RDBMS. It's not like the transaction are happening. They are using Hadoop as a backend. No, that's not happening. They are using RDBMS as a backend. On the night only, they are bringing it to the Hadoop, and whatever they are doing, one level of processing, two level of processing, three level of processing, and then bringing into some other RDBMS, whatever the analytics they are using. That's the whole point here. Every company uses that only. So the source I'm using it as a RDBMS.
No, Vinod's point is also valid, because there are projects which are directly bringing into RDBMS, and the entire project itself is in RDBMS. Sorry, in the HDFS, and then they will whatever the data they need for the reporting, they are just pushing back to RDBMS. That is also because of the storage and the cost they have to. For example, in AWS, if you are run against a query against the cloud, you have to pay for it. So that will be costlier. So that's why they are pushing back to the RDBMS, whatever the data they require, and running it at the local.
Okay,
that is also happening.
Okay, yeah, understood. Yeah, we'll move on.
Yeah, sure. Okay. So everybody, others is clear, like Ganesh ji and Challam ji, Vignesh ji and Vinod ji and Winston ji.
Okay, I just wanted to add
yeah.
one more point here.
Yeah.
Say in our company earlier we were using Netezza, and later on because of the Netezza cost and maintenance, they fully moved to cloud. They are not using any RDBMS system itself. So they are everything they move to cloud system.
Okay.
And reporting is happening on top of the cloud system where they have a Redshift or some other database. There they are running it against. So they are not using RDBMS itself. And the sources are not RDBMS sources. And we are using some legacy system like mainframe, DB2, things like that. So we put from those systems and put it into cloud. So RDBMS is not coming into picture here.
Yeah. So in the mainframe, if what kind of system you use in mainframe, where do you store the data?
In that they have DB2. So
Okay,
AS400.
DB2 is RDBMS, right? Again.
Okay, but
DB2
that's a
is
source.
kind of RDBMS, I believe. So it is some kind of source. Yeah. The point here is some kind of source you need to have. It is not like you must have RDBMS. No, it's not a case. But if I believe if you go into that mainframe, there we have some kind of RDBMS. I think DB2 is also RDBMS. That's why they have. Like it is not once you bring out the data, you have to manually go into Oracle or what is it, SQL Server or something. No, it is not the case. You can directly put into HDFS because you already, if the one more point why we are saying here is, what if HDFS fails? It's not failure, that's not the point, but they don't bring all the sensitive data, everything into HDFS as of now without having the copy in anywhere else. The companies are not doing that. All the sensitive data, non-sensitive data, yes, whatever they are bringing it here, they are processing, but all the sensitive data, they are not entirely trusting Hadoop till now. It has started happening. Some companies they might implement. In Bank of America, such a big line they might implement, but overall it is not happening.
Okay. Fine. I think we can talk about the cases, but it will keep on continue. So
yeah, cases. Yeah, still we can talk, but just because we are just trying to enter, so that's why we just want to make clear. That's why we spend some time on it. Okay. So those are the times which, what are the times we need to bring the data from RDBMS to SDFS and bring back SDFS to RDBMS sometimes to show the report and all. For that, what we can do is we can write a script and to analyze, process, and store we can do, and we can bring the data. So if we wanted to bring the data from RDBMS to SDFS, what we can do is we can export the data from SQL and then transfer the data into Hadoop. Like we can do the copy and then over there, and then we can create a schema in Hive, and then we can create script for each tables, and we can do those things. That is what we can do in a normal way if you want to bring the data from RDBMS to Hadoop or SDFS. But this takes time. For each table, we need to bring the data, we need to create the metadata, everything. So this is kind of time consuming. For that only, we use Sqoop. Sqoop is nothing but it's very simple tool. It just transfers the bulk data from Hadoop into external data source, which is SDFS. So it will run map reduce jobs on top of the RDBMS, and it will fetch the data and then it will push into SDFS. That's what Sqoop will do. And Sqoop will run on Hadoop cluster, and it runs map reduce jobs in the backend. And then what it does is it creates, it splits the data in the source table in RDBMS. If we have a table, if we have 100, let's say we have 100 records, it will split the data and then it will move it into Hadoop. It will move it into Hadoop target layer. That's what it will do. Okay. App only jobs are launched. Okay, we'll just do a see one demo how this happens. I'm just opening the terminal. So here I have MySQL, so I'm just using MySQL for the demo. Okay, start working. Service. Starting MySQL. Okay, I think we need to install MySQL. Sudo. I think MySQL is not installed, so I'm just installing MySQL server first. If it is the latest version, it is already installed, pre-installed, so we don't have to worry. MySQL should be available. Okay, it is installed already. Already installed latest version. What is happening then? MySQL I cannot connect MySQL sub service. Service unrecognized service. Okay, what's happening? MySQL server. So sorry, what's happening? MySQL connection. MySQL. Why is getting failed?
What's the password, Anbuji?
Okay. No, password is Cloudera. We have to set it.
For
No,
the
it's
skill?
installed, but I'm not sure what is the issue. I have to check the socket issues and all. Okay, I will check this one later. Currently, I'll just look and try to open the other version. There it might run. Okay. Meanwhile, we'll just go through this Sqoop. So, what happened is in Sqoop jobs, map only jobs will be launched. So, if you wanted to bring the data from RDBMS to HDFS, map only jobs will be started running. Only maps will run. There will be no reducers will run in Sqoop jobs. Only maps will run. And what happens in the behind node drives is once we submit the Sqoop job, once we submit, it will fetch the metadata information from RDBMS and then it will create a Sqoop job. For that, it will create, okay, we can specify the number of mappers here. So the default mapper is 4. If we specify the number of mappers, that much map job will run. The data, whatever the table we are going to move, that much data will be split. Let's say we have 100 records and our mapper is 4. Let's say our 100 record and our mapper is 4. Mapper we are only going to decide. We can decide M-4, then the mapper is 4. Our default is also 4. Then what happens is each mapper will transfer 25 records. And each will be put into separate files in the target folder. Part 1, part 2, like that it will put. Part 2. So from the top. Part 3. Part 4. So 100 records, once we give the 4 mappers, the data will get split inside itself and then it will put the data and it will run the mappers on top of the data and it will be moved into HDFS. Only jobs will run. There will not be any reducer will be run in Sqoop jobs. Okay. So this is how this will happen. Like once we submit the job, it gathers a metadata from RDBMS and then Sqoop import job will run. It will split the data in the RDBMS and then it will how much number of mappers is there, that much mapper job will run. That much data will be fed into that will be stored into HDFS.
Okay. Why do we have that the order will be in descending?
No. I just simply explain. It's not descending. It's like it will be there only 1, 2, 3, 4 only. I just mentioned 4 files. That's it. It's not descending. 4 files will be there. The file name will be 1, 2, 3 like that. 0, 1, 2, 3.
So this four file means it is going to be used in the same cluster or different blocks?
It will be in HDFS one. HDFS it will be same cluster only. Always cluster is one only. Blocks and behind nodes that will happen in the backend. Like how the HDFS is stored, like that it stores. Where which data node is free, there it will get stored.
So always each data node will have 4 parts?
No. Here we have 4 mappers.
Right.
For this Sqoop job, we have 4 mappers, so 4 files generated. We can increase the mappers. Let's say you are doing 8 mappers, then 8 output file will be generated. Mappers is in our control. If we increase the mapper, the parallelism will get increased. So if we increase it, let's say 100 records, currently it is running 4 mappers, then each is splitting into 25. If we increase it to 10 mappers, then each mapper will like transport 10 records. 10 mappers is there, so 10 files will be generated outside, correct? That's what happens.
So does the one mapper to the one data node? It's not right.
No. Data node, you forget data node and all. That is not at all coming into picture here. That much files. This is file. Each HDFS files will be generated. Files.
So the number of split in the records will be decided by Sqoop itself, or
Number of
the number of records,
2 records.
number of
That is,
mappers, or otherwise.
number of mappers is decided by us. If we did not give anything, like default is 4. Default Sqoop is 4 mappers. If we want to change, we can change.
How fast it will be?
Uh,
I think Arji, the question was whether it's always equally distributed from the record perspective based on the mapper, or it will be random, the number of
it will not be equally distributed. It's based on the primary key. So there we need to take care of the primary key. If we give the primary key wrong or something, then some mapper will get loaded more.
Okay.
And how fast it will be?
It is in MapReduce, it has to run the job and all. If we transport long data, like more data, then it will be much faster. Like much faster means it will be sensible. But if we transfer small amount of data and all, also it will take some time. Like instead of normal data transfer, it will have some kind of lag, like 1 minute or 30 seconds it will take. Let's try. Okay, here like my MySQL is running. We'll just run the Sqoop job. I'll show you. I'll run the Sqoop job and show so that you'll understand how this works. So use. Okay. So here we don't have any data. Do we have any data? World data is not there. Okay. So for example, I'll just import some sample database. This I downloaded from them, like MySQL server, their homepage itself. I will just import the database into my MySQL for the sample data. Okay. Go to import data from MySQL student table. Import. So practical. One minute. That is done. So, so first step is importing the data into MySQL. Currently, I don't have any, like I have some other databases. I have FDADB, TravelDB or something like that, which I can use. But for example, I will use this, whatever I'm going to insert only. I'm just uploading, like importing the SQL file. This is the database file into my MySQL for my purpose, just for demo purpose only. Show databases. So now I have this database. I'm just importing this. So for the importing, what I use is I use this command source, and then I use the file. Then it is loaded into my MySQL. So just I'll use the world show tables. So I have 3 tables. I'll just move one table to HDFS first. I'll just do that. That's what we'll do. So if currently for MySQL there is a jar available. There is a MySQL connector jar available already, so we don't have to put anything. But if we wanted to move the data for any other database such as MySQL, like SQL Server or Oracle or Teradata, for that we need to download the particular jar. They will provide the jar. We need to copy and then put it into /user/lib/sqoop. Understood? Here we need to put the library jar. From there only it will like what will be there in the library jar. nothing. It will have the all the codes to connect to how to get the metadata, and all those things will be available in the jar only. Because without that jar, we will not be able to run the Sqoop jobs. So that jar, connecting jar, we need to put into the /home/user/lib/Sqoop. And if you are running in office environment or production, it is already done by admin. We don't have to do anything. Fine. So now I just checked the data is there in the city, country link. There is a data. So let's start from city. So there are some kind of data is there. So we'll just try to move it. Okay. So that should be fine. We are ready to import the tables. And importing is very simple only. All we need to do is Sqoop import. This is a Sqoop import command. This is a Sqoop. This is syntax. And then we need to connect it using, we always connect it using JDBC connection only. JDBC, MySQL, and this is my IP address, localhost.
So you are importing from where to where?
We are importing from RDBMS to Hadoop.
Okay.
This is called importing. If you do the reverse, that is called exporting. Okay. Currently, we are importing RDBMS to Hadoop. Sqoop import. After that, we give the connection string. In the connection string, we'll give the database name also. Like this is my IP address and then the database name. And then what table we want to move. Here I have a table called city. So I'm moving that table into SDFS. And then username of the particular user and then password. Okay, username root. Let's run this and see what happens.
RJ, one question.
Yeah.
There, you didn't mention any of the target location, correct?
Yeah, correct. So target location, we don't have to mention here if we are moving the table. And what happens is it will create the table name itself in the target.
No, that I got it. But where do you, where it refers that it goes to HDFS file system?
Import. Whatever, if you mean Sqoop import, that is means import. That means that's where we mention.
But that import is a process. But what is the target location?
Yeah, target location means you're saying which folder or which file system.
If I want to put it in particular folder, how do we do that?
No. Before going to that, see, we know that by diagram it is going to HDFS, but where you define HDFS is coming?
That's what we mentioned it in Sqoop itself. If we specify Sqoop import, then that means import means like RDBMS to HDFS. Import means itself HDFS. Whatever it is like configured, whatever the cluster is configured for that Sqoop, it will move there only.
So that's on the root table. That's on the root. That's on the HDFS root.
HDFS root table. Okay. Okay.
So the directory
I think now the other question was if I wanted to put it into some other route instead of putting into the same location.
You can do target directory. Target directory you can do, and then user Cloudera test there. But the directory should not be available already in SDFS. That is a prerequisite. If that is met, then it will work. Target there and then. So if you see, there is one SQL statement is getting executed first. That will check whether the table is exist and any issues with that, something like that. That will check, and from that only the MapReduce jobs will getting generated. And after that, there will be one MapReduce jobs will get generated in the back with the jar. So if you see here, city.jar is generated here. After that, it looks like you are importing from here. And what is the issue? Connecting resource manager, quick start Cloudera. Okay, is there any issue with this? And bounding values query, it is created. These things you will see. And number of splits is 4 because we did not give any mappers over there. It took defaultly 4 mappers. and the job is running.
Arjit, there is no reduce, right? Why they have a map 0% and reduce 0%?
No. Like once a map is completed, it will be completed. It is just a showing. They're showing. Once map is 100, it will get completed. Reduce will not run. It will not show. And here some issues with the jar version. That is why it is showing the issue. Here are setting major minor. It is due to some Java version issue. So that's why it's happening. So this is a known issue only. Like,
I think you are also on 5.8.
Yes, sorry.
You are also in 5.8.
5?
Yeah, you are in 5. The Hadoop version 5, I think.
No. I Hadoop version 5.8. That is fine. But here, what's happening with this Java 8 and Java 7? So I was doing some kind of changes in the Java version that messed up the things. That's why it's not running. So anybody else having the cluster system, you can start sharing. Will run in your machine itself. That is fine. Anybody is running? If anybody has the system, we can run in your system itself.
I can share my system.
Yeah, sure. I will just okay. Before you share the screen and also open the share folder also. From there only you need to download all the files and all. You can share and we'll run the demo today in your system. Tomorrow we'll see. Okay, you can share the screen.
Okay. And
Yes, loading.
Arumugam?
Yeah.
So you showed the SQL terminal, right?
Yeah.
So that is the same for the HDFS terminal, or it is switching back?
HDFS terminal.
You showed the MySQL databases.
Yeah, MySQL database I showed.
So it's on HDFS itself. You showed us.
No. MySQL is not an HDFS. That is just a MySQL only. It is RDBMS. It is outside.
But you showed it in Unix.
HDFS. No, I showed in. Okay. The same system it is residing. Yes, it is in the same Cloudera.
Okay.
The same server it is running, but it is not inside HDFS. It is the same server.
Okay, but on this, it is the same Cloudera, but it is in a different terminal.
Yeah, correct. Different terminal.
Okay.
Are you on the control?
Okay, now I can hear. Okay, now I can see. Okay, now you can import the data. You can actually do it very simple only. And you copied that files?
No, I didn't do. I just went to only SQL. MySQL.
Okay. Can you copy the world.sql and put it into desktop? From the cloud, share drive.
From the share drive.
Outside, we need to go out.
So from the Google Drive you're talking?
Yeah.
From the Google Drive, right? It's under the today's session, or where is that?
Yeah, it should be an assignments. Go into assignments. Go into Sqoop.
Which one is that?
World.sql will be there. SQL file 394 KB.
This one, right?
You were able to find?
Yeah.
Okay, that's good. You can put in the home for like desktop here as well. Just for desktop.
Let's see, I can do this. I can put in my desktop. From my desktop to I need to put it into Hadoop. I know I can do one more thing.
Here.
I'll open here.
No, you can put it in your home only. Like.
No, that will be my personal desktop. So then I have to put in a Hadoop, right? I have to
Yeah,
put
no,
in
inside only. Inside, if you minimize the Firefox, minimize the Firefox.
Okay.
Firefox, not the quick system. Firefox, you have to minimize.
Minimize. Let me put here. I cannot put.
Paste is not there. You have to copy it and then paste it.
That's challenging.
Is it copied from the personal desktop properly?
I'm directly copying from the
cloud, right?
Yeah, cloud.
Okay, then you have to download it in your personal desktop and then try copying and then delete it in your personal desktop for time being.
Okay. Just a notepad. Save that as save this file. Make that to my okay. So yeah, it's there in my downloads. So you want me to copy this, right? No. How do I move from my desktop to Hadoop?
Go to your desktop, copy there, and then paste it here. It will work.
See, this is on my desktop. Okay, download.
Okay. You copy there, right click copy, and then come inside paste. How did you bring the Hadoop jar? Same way you can bring that.
Hadoop jar, that's okay.
It came right. Cool.
Yeah.
Yeah. Now what you can do is you can just run this one. Type this one. Source. And run this. I'm just running this in chat. Like source, and then can you type here? You can give the source. You can type. I just given the command in the chat box. You can copy and paste that also. Source, and then give the entire path. It will load it. It will get loaded.
Okay.
Yeah. Yeah, it's loaded, and then you can open one more terminal. And run this.
So I should go to okay. Hadoop.
No, you can run from here itself. Given the command, just copy and paste it. Hadoop import. No, not Hadoop. You can delete it. No, you can just type the command. So like Sqoop import, I have entered. Just not this.
Okay.
I have entered another command. Just from the Sqoop import, you can copy and paste it.
Okay.
Yeah, you can
Sqoop
maximize
import.
the screen. Yeah, let's see if this works. So yeah, replicate city jar is created and SQL. Okay, we'll go up. See what is the error. Yeah, go up. Oh, wait. Remove this. Okay, can you open the currently what is the exception is saying is Hadoop name node is in safe mode. So we need to restart the server. Go to Cloudera manager and then restart the server. Down there. Right side Cloudera quick start. Up there, right side Cloudera quick start. Yeah, just click the down arrow. No, not there. Back. Go back. Click the down arrow, and then restart. Yeah, it will get restarted.
Okay. So do we need to Sqoop also? Do we need to start the Sqoop also?
No. Everything it will get started. We need to give some time. Everything will get started here. Start all. Now it is stopped. Now it is starting all the services in cluster. Right. It will take some time, but it will get started.
Maybe I may get again an issue probably because of I don't have an
RAM. Okay.
no the jars. No, the RAM is fine, but I probably may need to update my jars also.
No. That is a different one. That is a map reduce jar, right?
Okay. Yeah.
This is not a map reduce. Map reduce jar is not required for Sqoop.
Okay.
So it should work.
It could take us 6-7 minutes.
Okay, you can stop sharing, or you can like share the screen once it's started.
Okay.
Meanwhile, let me start sharing. So I'm also running the same Sqoop command. So it is job is submitted. Let's see if this map is completed or it is getting errored out somewhere. Now it is, yeah, tell me.
Now, what is the service need? I mean, what is the jar needed for this?
Currently, in the latest version, all jars are available. So just now, as you can see, the job gets completed here. So it doesn't need any jar in your new version.
Okay.
New Cloudera, there is no jar needed. That jar already comes with the Cloudera itself. Okay. Anyway, so here it is completed. Once it is restarted, you can also start the same command. So we'll just go ahead with the class for this one. So it is started and it runs a map reduce part. After that, it's a map part only. After that, it stops. The reducer did not even get started. Okay, so that's why it is a map only job. And if you see entire thing, it is retrieved totally 4079 records, and we'll see what is the output where it is stored. Hadoop fs ls/user/Cloudera. So here we did not give any target directory. That is why it is directly stored in the city directory itself. It created city and then it's stored. Hadoop fs ls. Let's see what's inside. We have 4 files here, nothing else. See, we have 0, 1, 2, 3, 4 files here, and every file will have 25 records. That's how it's split.
I have a question.
Yeah.
So if I do one more time, will it overwrite the same file?
No, it will throw an error. I'll run the same. It will say the directory exists. You have to give the target directory to avoid it.
So once the file is stored, so when we are doing an incremental or when we are doing a reload, it should be into a different files or altogether different directory.
Yeah. You can have one more option is there in Sqoop, which is called incremental update. In that case, you can give the same target path. If you want to handle it manually, then you have to change the way we work. Then we have to create new folder and then do it.
Okay, then the incremental, how it will work? It will update in the same
folder. It will put the extra files. Like it will create new file in the same folder.
So it will never ever overwrite the existing file, right?
It will not overwrite. Yeah, it will not overwrite.
So it is as like in Hive.
Yeah, it will just keep on loading it.
Okay.
But if we have one process for incremental load that is different. So for that, what we do is that's kind of a bit confusing. Anyway, we'll do. So we will push the data from here to Sqoop, and it will create new folder. And once the data is there, we'll run one shell script to move the data from here to one Hive table. There we handle the incremental load. After that, we'll delete this file folder itself, so that next day it will come. We handle this as a staging table, staging folder. This is the way we are handling. But yeah, incremental load if you use, that is also fine.
But will it be added next year? Will it again add to the Hive table or? Yeah,
Hive table it will be added. We are just moving it only. Hive table is in our control. That is very easy. That is daily one file will be added here. One file will be added here.
It is only one file. Same in that is what in the Sqoop also, right?
No. Sqoop is different. For some specific purpose, we did this. We don't want to go for the incremental. That is having some constraint in Sqoop. That's why we used our query to handle the scenario. In that scenario, we will not be able to use the incremental load. That's why we handle it in a different way. Anyway, we'll come to that. We'll come into that tomorrow.
Okay. So when you are storing it in multiple files, so will it be the Hive or Sqoop will know that, right? How to relate it?
Yeah, of course. That is Hive's Hive will know. But structure should be same. You can have multiple files. Structure should be same.
Even Sqoop also, right? When it is loading as 4 or 10 different mapper files.
Yeah. Sqoop knows, but Sqoop is not Hive, right? Hive is only data warehousing. Sqoop just loads the data. So it is.
Okay.
Hive knows.
So
if you have multiple files, Hive knows.
Okay. So then again, while loading, we have to specify all 4 different files to get into the Hive.
You have to bring all the data into Hive to handle into Hive. Yes.
No. In the Sqoop, we stored as 4 different files, right?
Yeah, correct.
It's created 4 different files. So we have to explicitly specify with the 4 different file names. Then only it will bring it to the table.
No. You don't have to specify. If you want to create external table, you just give the path. Then it will take automatically. It will read 4 files. How much? In Hive, we always deal with the folder only. Like you have 100 files in one folder, it will read 100 files. Hive. Okay. So Hive will see Hive in that case. Hive is just a metadata. It will take care.
Okay.
So if we are going to use that Hive, that means that so we need to use the Sqoop first on the Hive, right?
Yeah. Sqoop and
or
then
directly Hive. Or directly Hive.
Or directly also you can bring the data anywhere else. From other ways also you can use Hive. Yeah.
So Sqoop, it won't be suitable for the multiple loads. Only one time. So only one day, right?
No. Delta load also you can handle in Sqoop. like I said, one particular scenario, it is not, but even though we are handling it in a multiple load only, right? Delta load 100% we use high only, sorry, Sqoop only. Without Sqoop, we don't use anything. Delta load, it is possible, multi-load, everything is possible only. But we have to handle in a different way for our use cases. Like what I am talking here is a very specific use case to one project. They might have some constraint. They might not have the primary key. They might not have the distribution methods. So a lot of things comes into perspective. This is just one specific case. If you want to incremental load, there is one specific code is there in incremental itself. You can just use it and that will just do the incremental load. There are a lot of availabilities there. All right. So that is possible. And how Sqoop like split the data under the hood is, it will take the maximum and minimum of the number and divided by the mapper. That much number of mappers will run. That much number, that is the split size. Okay. So anyway, that and all we'll see tomorrow only. Today we just start intro to Sqoop only. That should be enough, I guess.
Aru, just one question.
Yeah, we can have question.
If you are planning to cover this one in future, that's fine. You don't need to answer that right now. You mentioned that if we are moving a file into a folder through Sqoop, the structure should not change, right?
Yeah.
HDFS is a schema on read. It's not schema on write.
Correct.
So if I'm moving 3 columns today and my source table is getting changed with 4 columns or 5 columns tomorrow, right? When I write it, anyway, Sqoop is going to write it in the same folder with a new partition with a new file, right?
Correct.
So when I try to read that in Hive using my new structure, will the old if I try to read the old file which is just having 3 columns, will it abandon or will it will go through? Still
it will go through. Whatever the new column you added will be shown as null.
Okay.
Because it is a schema on read, you will not receive any errors while loading. Only while reading only, it will show as a null. It will not throw any errors.
Okay, thank you.
Yeah.
So, I think Aruji, one question here.
Yeah.
Because this one is a smaller table. Suppose if I'm just using a Sqoop to pull something around a 1 million record. So can I able to multiple tables simultaneously, or I need to do one by sequential like that?
You can run this tables one by one only, but you can increase the mappers. If you want to run a particular, if you want to run a like parallelly, you can create specific Sqoop job and run it parallelly. Start at a time, then it will move. Yes, there is a possibility.
Suppose if it is a production environment, suppose I want to extract something around 100 tables from Sqoop, using Sqoop from my source system. So in that scenario, I need to run all 100 tables will go in a sequential manner, one by one.
That we have to decide based on the load, because you can run 100 job in a like cluster. If you have a cluster resource available, because it is what it is doing is background, it is running a map reduce jobs only, map only jobs. So if you run 100 map jobs, if your cluster will load, cluster will handle the load, then you can parallelly start all the 100 Sqoop jobs. There will not be any issues. It will run.
Okay, got it. Thank you.
So we can run one after the other in a shell script also, right?
Yeah, one another also you can run. You can like sequentially also schedule the jobs. See, what we have just now seen is just move one table only, right? There are there are sometimes what time you want to move all the tables, the entire database you get a copy, and sometimes what you want to do is you want to do the join 2 tables and then bring the results. That is also possible, query. So those things we'll see tomorrow. Those are the variations. There are multiple variations which we need to do, which must come into projects, right? Those we'll start seeing tomorrow. And how it is getting split, that also is a very important thing. Like in this, whatever we see here, it is properly distributed, evenly distributed somehow. But sometimes one file will have 100% load. At what time? So those things we'll see. Those are the variations which we need to go into deeper to understanding of Sqoop. But till now everybody is clear.
Yeah.
Yeah, Sankarji,
Yeah, yes.
Ganeshji, Anandji, and
So,
Anandji.
so as a summary, Sqoop is mainly extract the data and put it into HDFS.
Yeah, extract data, yeah, correct. And reverse also, import and export from SDFS to RDBMS. That is called Sqoop.
Okay, then I have one basic question. Probably you may cover it later.
Yeah,
so, what is the difference between Sqoop and Spark?
Sqoop and Spark, first of all, it is not comparable. And Sqoop is just used to bring the ingestion. It's just an ingestion tool. Sqoop is bringing the data from RDBMS and bring back to SDFS. Spark is it's a framework itself. It is it's used for processing and all. It is a framework. So that.
But even in the process, we can do the ingestion, no?
You can do the ingestion, but that you can do multiple things with Spark, right? It is not just do the RDBMS ingestion. No, you can do multiple things with Spark.
Correct. But if I have then what point that we can determine that we can go for Sqoop or Spark?
Okay. So what point you should determine is Spark is very memory intensive processing. Correct.
Okay.
You have to go for the memory intensive processing. It will run in memory processing. So if you have the cluster size and everything is fine, and then you can go for Spark itself. You can move like connect to the SGFS and read it. Connect to the
Sqoop is like FTPing the file.
Yeah, kind of, yes. Sqoop is like FTP.
And also Ganesh, did you use ETL tool?
Sorry, what was your question, Vinod?
Selvam, are you working any ETL tool like Informatica, data stage like that?
Yeah, Informatica.
Yeah, that the Sqoop is a kind of a source stage. It will extract the data from the RDBMS, and the Spark is like your transformation. Whatever you want to do some calculation, or you want to do analysis the data like that. Your business rule is implemented through Spark.
Sqoop, yeah, the Sqoop could be like a data loader, just to load.
Yeah, it is just an ingestion, data ingestion.
I got that point, but my point is that should we need to have a separate Sqoop for a data loader where we can do it within Spark itself? Because Spark can do data load, ingestion, and transformation, correct?
Yeah, correct.
Yes.
Spark can do that.
Yeah, in that case, should I need to have a separate Sqoop?
Yeah, as per the current scenario, that's what we are doing. Because once you bring the data from RDBMS to they put it into the SDFS. From SDFS, it is leading. But yes, that use case is also possible. Like you can directly read from RDBMS and you can run. That is also possible.
Put it into Hive table. You put it into Hive table. That is
correct. You can. In that case, what happens is Spark directly connects and read it and do processing and store it into Hive.
Hive. So I don't need to go for Sqoop in that.
You don't have to go for Sqoop. Correct.
Okay.
That is also possible, and that's a possible scenario.
Yeah. And thanks, Selvam.
Yeah.
I understood, but I'm just thinking, why do we need to have?
Yeah, that is a correct question. Exactly, that's a protection.
No, your your question is correct. We are also got some idea right now. Yeah.
So, Vincent ji and Vinod ji and Vignesh ji.
I still get a failed mission.
Yeah.
So do you want to look at it?
Yeah, so today class is completed. If anybody wants to leave the class, you can leave. And thank you everyone for attending today's class. I hope today's class is useful and interesting. We'll see you in tomorrow class. If you have any doubts or any issues, you can stay on the class. We will be there in the next 10 minutes. Yeah, thank you. Thanks everyone. Yeah, and Buju.
Thank you.
Thank
you. Yeah, thank you.
Bye.
Thank you.
Bye.
Mission, okay. I'm getting there.
You are getting again which import error, right?
Yeah.
Okay, go down. What is the error now?
I think it's same.
Okay, wait. Go up. Same error. Okay, go up. Go up. Okay, wait. APC name node is in safe mode exception. Cannot delete storage name node is in safe mode. After you restart, also same thing happened.
Yeah.
Okay.
And when I restart, I think everything is restarted, but only the
Zookeeper.
Zookeeper only did not.
Okay, check HDFS health. We can manually bring out the HDFS from safe mode. That is possible.
Health, is it here?
Health of HDFS, what's happening? No, not here. In Cloudera Manager itself.
Okay.
You have the health monitor, right?
Right, yeah. Okay. There's no health issues.
No health issues, right? Okay, then do one thing. Try this and like run this in a shell, like in a terminal. Yeah, I just sent one command to remove the HDFS from safe mode. Actually,
from the root node, right?
Yeah. Here, just you can copy and paste it. We now run the Sqoop command.
This one, right?
Yeah, that one, correct. Something issue with the like hard disk only. That's why it's having this.
Okay. Is it something Java issue? I don't know.
Which one? No. Oh, go up. Okay, again same issue, right? Replied. There are three. Okay. So what is the issue? It is issue with the data node. It is not issue with jar. It is an issue with data node. If you see Hadoop remote exception, there is no data node is available. So one thing you can do is you can delete this one and re-import the entire thing again. You can you can shut down this and remove this quick start VM itself and then connect a new one.
So you want me to restart?
Shut down.
Okay.
And right click delete and then delete the one and extract new and then start from the beginning.
Delete. Shut down MTP. So you want me to delete what? Not this one. Oh.
Go into MySQL. MySQL run பண்ணி பாருங்க.
அது MySQL போக மாட்டேங்குது. அது என்ன?
MySQL -u போட்டு ரூட் போட்டீங்களா?
-u
-u root. ஸ்பேஸ் -p கொடுங்க. ஸ்பேஸ் -p கொடுங்க. கொடுத்துட்டு க்ளவுட் ரன்.
பாஸ்வேர்ட்
-p பாஸ்வேர்ட் வந்து க்ளவுட் ரன் கொடுங்க.